Well, the good news about graphing inequalities is if you can graph an equation, then you can graph an inequality. So when you have something like this first example, where we're graphing y is less than or equal to negative 2/3 x plus 3, we're just going to graph the same way. We're going to graph what's called the boundary line. So our boundary line is just the equation y equals negative 2/3 x plus 3. So we're going to make a graph. And we will, don't forget to scale your axes. So I'm going to count by ones. And then we're going to graph just like we did before. So our y-intercept is positive 3. So I'm going to plot the point 0, 3. The slope is negative 2/3. So I'm going to go down 2 and to the right 3. Always make sure you double check. It's a negative slope. Our line should be going down from left to right. Or remember, we can also go up 2 and to the left 3, as long as one of the directions is negative. Now, before you connect this and make the line, there's one thing you have to think about, and that's this symbol right here. Because it is less than or equal to, we're going to make a solid line. When it's less than or equal to, or greater than or equal to, we'll draw in a solid line. Just like when we had inequalities just on a number line and we did a solid, or we filled in the dot, and if it's less than or greater than, we're going to make a dashed line. Just like on a number line when we were solving inequalities like x is less than 5, and we made an open circle, for a linear inequality we'll make a dashed line. So in this case, we're going to have a solid line. All right, so far it's just like graphing a line. But now, because it's an inequality, we need the values of y that are less than the line. So one thing that you can do, a good way to decide, we're going to be shading one of the sides of the line. So we're going to test a point. I'm going to use 0, 0 as my point I test. And this will work as long as my line does not go through the point 0, 0. If it does, I'll have to choose another point. So I'm going to test 0, 0 and plug these values in for x and y into my inequality. And if I do, I get 0 is less than or equal to negative 2/3 times 0 plus 3. Which gives me 0 is less than or equal to 3. Now this is a true statement. Because it's a true statement, I'm going to shade the side of the line that includes 0, 0. So I'll shade, I'm just going to do it like this, but I'll shade this side of the line. Now what that means is every point on this side of the line will make the inequality true. For example, suppose I chose the point negative 3, 1. Well, that's in that region that I shaded. That means if I plug in these values for x and y, negative 3, 1, I'll get a true statement. So if I plug a 1 in for y, let me just show you that that's true, and a negative 3 in, oops. So I had negative 2/3 times a negative 3 plus 3. So I'm just substituting the values. These will cancel, which is why I picked negative 3. So we get 1 is less than or equal to 6 plus 3, or 1 is less than or equal to 9. And that's a true statement. Anything in this region will be true. On the other side, however, anything on this side will be false. For example, if I were to use the number 3, 4, and if I plug those values in, 4 less than or equal to negative 2/3 times 3 plus 3. 4 is less than or equal to negative 2 plus 3 is 1. Well, that's a false statement. which is why all the points on the other side of the line are not shaded, because those would create false statements. But anything on the shaded side makes a true statement. So your solution to your inequality would be all the points that are shaded on that side of the line. For this inequality, I'm going to use the x and y intercept method to graph my line. So if I let y equal 0, I can cover up the 5y. If I let y equal 0, then I get 2x equals 12, or x equals 6. So I know my x-intercept is 6, 0. And if I let x equals 0, then I get y is 12 fifths. So I'm going to have 0, 12 fifths, which is 2 and 2 fifths. So that's about right here. Just approximate it. Now this time, because it is just greater than, we're going to have a dashed line. My boundary line will be dashed. So here's my dashed line. And now I have to decide which side to shade. So again, I'm going to use 0, 0, because remember, I can do that as long as my line does not go through 0, 0. So if I plug a 0, 0 in, I'm going to get 0 plus 0 is greater than 12. Well, this is false, which tells me to shade the side that does not include my test point. So I would be shading this side. All the values on this side of the line will make the inequality true. On this example, again, I can use the x and y intercepts to graph this. So the x-intercept, if I let y equal 0, I get 3x equals 12, so x is 4, so 4, 0. And the y-intercept, I'm going to end up with negative 3. So we have 0, negative 3. Remember how I'm doing that. I'm letting x equal 0. So then I get negative 4y equals 12. So I divide by negative 4. So it's really easy to do in your head if it's in standard form, which this is. So I'm going to have 4, 0 and 0, negative 3. Before I connect them, I have to think dashed or solid. So hopefully you realize that this is going to be dashed. And then once again, I test a point. So again, I can test 0, 0 since my line does not go through 0, 0. I get 0 minus 0 is less than 12. 0 is less than 12 is true. So that means I need to shade the side that includes 0, 0. So I'm shading this side of the line. The next example is kind of special. And this is one, hopefully you remember, as I've told you, you just really need to memorize this, that when you have y equals a constant, remember that this is a horizontal line. And if you remember that, things will go easier for you. So I'm going to plot the point 0, 2 because it's a horizontal line that goes through that point. It's just strictly greater than, so that tells me I need it dashed. Now, you can still plug in a point 0, 0. Of course, there's no value for x to plug it in. Just plug in a 0 for the y, and you get 0 is greater than 2, which is false. So you're going to shade the side that does not include 0, 0. In our last example, and hopefully you know what kind of line this is, remember that x equals a constant. There's a vertical line. So we're going to have, I'm going to mark the spot for 3. Now this time, because it's less than or equal to, we're going to have a solid line. and it has to go through 3. So here's my line. Now I have to pick a side to shade, and I can do the same thing. I can test 0, 0. I guess I should have had an example where 0, 0 wouldn't work, but at least I'm telling you, if the line goes through 0, 0, you have to pick another point. So here we can pick, substitute a 0 for x. We get 0 is less than or equal to 3, which is true. So I need to shade the side of my line that includes the 0, 0. So we end up with this side shaded. Okay, I decided to do one more. So on this one, if I let x equal 0 and solve for y, I get y equals 0 for my y-intercept. And if I let the y equals 0 to solve for x, I get for the x-intercept, I get 0, 0. So I should have called this the y-intercept. So here I only have 1 point, and I need 2 points to make a line. So you could substitute another value, or I am going to write my equation in slope-intercept form, which means I need to solve for y. So I get 3y equals negative 2x, y equals negative 2/3 x, which tells me I have a slope of negative 2/3. So from this point, I can go down 2 and over 3. Or I could have gone up 2 and to the left 3. Now, since I'm going to have a solid line on this one, so here's the line. And now I have to decide which side to shade. Well, I can't test 0, 0 because my line goes through 0, 0. But I can test anything else. So I'm going to test 1, 1 because those are pretty easy numbers to check. So I substitute a 1 in to both places, and I see if this is true. 2 plus 3 is 5. 5 less than 0, that's false. So I want to shade the side that does not include 1, 1. So I'm going to shade this side. So that's all you have to do if it passes through 0, 0.